So this is 2.1.13, and the learning objective is to construct a logic diagram using AND, OR, NOT, NAND, NOR, and XOR gates. Logic circuits or diagrams are constructed using the Boolean operators discussed in section 2.1.11 and are implemented by logic gates. A logic gate simulates a specific Boolean operator. So a Boolean operator takes either one or two inputs and returns one output. So the logic gates in IBCS are written as circles with the name of the gate inside of it. There are 6 logic gates which can be seen on the right. You have AND, OR, NOT, NAND, NOR, and XOR. All the logic gates have a single output on the right indicated by a line. The NOT gate has one input, whereas the rest have 2 inputs. Here we have a summary of logic gates and Boolean operators. So the AND gate outputs 1 if both inputs are 1, otherwise outputs 0. The OR gate outputs 1 if at least one input is 1, otherwise outputs 0. NOT outputs 1 if input is 0 and 0 if the input is 1. NAND outputs 0 if both inputs are 1, otherwise it outputs 1. NOR outputs 1 if both inputs are 0, otherwise outputs 0. And XOR outputs 1 if only one of the inputs is 1, otherwise outputs 0. So here is an exercise. Draw a logic gate for the following statement: not A, or B and C. Here is the answer to the previous question. So here we see one input A for the NOT gate and 2 inputs B and C for the AND gate, and then the final gate OR connecting the outputs for the 2 previous gates. So for this question, determine the output of the following logic diagram if A is 1, B is 0, and C is 0. So here the output would be 1, although the XOR gate would have 2 inputs of 1. It would output 0 because the XOR only returns 1 if and only if one input is 1. Another question. Draw a logic diagram for the following statement: A NOR B, XOR B NAND C. So here is the answer to the previous question, and I hope you understood how to construct logic diagrams and how to understand logic diagrams.